So now in this video, our goal is to charge a capacitor to a certain voltage. I'm going to aim for about 2.5 volts and not charge higher, even with a higher power supply right there. And the way we're going to do that is with an NPN bipolar junction transistor, the 2N3904, wired as basically an adjustable zener diode for the most part. So how much voltage it takes to make it conduct will depend on the position that we have on the trimpot right there. So that's a lot more to investigate later on. For now, just realize we will set a voltage. So to know the voltage that we set, we have a diode here to charge the capacitor. And then also we have a resistor here because the diode will let the capacitor charge but not discharge. So while we are making our adjustment, we won't be able to lower the voltage and see that unless we have a resistor discharging the capacitor slightly. So we're going to use a high value capacitor. Mostly it will stay charged to the voltage we set, minus about 0.6 volts. We have a diode here so that it can charge, as I said, but not discharge that way. Because if we cut the power, then current's going to go through that trimpot. Also, my power supply gets a slightly negative voltage when it's off for some reason, so it would discharge through the power supply. So the diode prevents that. But whatever voltage we set with the transistor, we will lose about 0.6 volts when we come to the capacitor. So we will just measure the voltage directly at the capacitor. This resistor, when we cut power, the capacitor can't discharge, so this resistor will give us a chance, if we lower the voltage below what the capacitor is, to discharge very slowly. So you'll see a slow decline in voltage. You would remove that once you have a setting that you like. Then you can charge the capacitor, it'll stay that way. We have to limit current. This will just keep letting current flow once we get above the voltage it's set to. And so we have to limit current. So again, this is just basically a prototype circuit, not a terribly practical circuit. We're going to go to 2.5 volts. But it's an interesting one, and you learn a lot of electronic principles just by doing sample circuits like that. And here's the circuit. So we have a 1000 microfarad capacitor. It can be charged up to 35 volts, so we're nowhere near its limits. But if for some reason you're using a power supply that is higher than a capacitor can handle, you want to make sure you have this all set beforehand. But in any case, there we have that. We have this 1 kilo ohm resistor, and then the diode right there. You can see a gray stripe probably right there. That's the cathode, so that when that's more positive, current can flow and charge the capacitor. Now we do have this resistor just temporarily to help bring down the capacitor voltage, especially when the power supply is off. And that's just so we can raise and lower the voltage above there. Without that, once we raise the voltage to a point, the capacitor is just going to stay charged even as we lower the voltage there. Now the 1 kilo ohm resistor also comes to the collector, as does the top of the trimpot. So this trimpot, the middle pin is the wiper. That's important right there. There's a resistive element that comes across, that goes to ground, as does the emitter right there. So both of them are connected to ground, and they're both electrically connected directly to each other. And the wiper comes to the base to help set the current to get it to start conducting. So in any case, that's it for the circuit. Right now, remember, once we set it, we remove that resistor, so when we cut the power, then the capacitor will hold its voltage. And now zooming back, you can see we have 5 volts right there, and I will turn the power supply on, and so you're going to see endless current flow because the transistor never starts conducting because we have a higher voltage than what we are setting. We'll zoom in a little bit, we can look at that real quick. 5 volts there, and then we'll see that we'll come to where the capacitor is right there. We'll see the capacitor voltage. So these alligator clips come from the cable there. I clipped them to jumpers so I can easily move them around. But there you can see I already set it to about 2.5 volts. Now what we're going to do, okay, I guess that's about as dim as this lamp will get at this setting. So you're going to see if I turn the trimpot down a little bit, the voltage actually goes up a little bit. So we got a little closer to ground. The voltage went up. Now I'm going to move it slightly that way. So it's only lowering right now because of the resistor. So it's going to go slower. So we got to kind of set it and then wait for it to settle down right there. And so we're going a little bit lower. So that's good because we can raise it quicker. So I set it too low, and So it's not that quick adjustments, but it's not terribly bad either. So turning trimpot the wrong way. There we go. Want to go down a little bit. There we go. Now it'll bump up quick as I turn the trimpot a little more to ground. So there we go. So we set it. That's close enough to about 2.5 volts for my concern. So now we remove it, and we'll see that we limited the voltage there to the capacitor. And if I turn the power supply off, so the output is off right now, now the capacitor is holding its voltage right there. So we did that. Now what we're going to do, we already set it. Let's just run with that. I wasn't going to put the resistor back, but I can't see where I put it right now. I'm going to move this up to 10 volts and turn the power supply back on right there. And you can see it did bump up a little bit, but it's still really close to the voltage that we set right there. So probably not good for this big of a voltage swing for a practical circuit, but even with this, it's not terribly bad. It changed about 0.5 volts. And we'll go up a couple more right there. And you can see 12 volts. It is still holding steady right there. And again, if we cut the power, it's going to hold its voltage for a while. So, in any case, that's really about it. Again, this isn't a practical circuit, but it's a good one to look at. You'll understand electronics a little bit better. And so thanks for watching. Make sure you check out one of the other videos I'm posting. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out a ton. I will see you in the next video.